Okay, I'm going to talk about meteorology today for piloting. All right, so we are studying applied meteorology. Here are some questions. These are some test questions. I'm just going to go over them. All right, what type of turbulence is caused by a very warm surface temperature and uneven heating of the Earth's surface? That's convective. Think about convection like a stove or oven heating the Earth's surface. So that's convection. Okay. All right. Here's a true or false question. If you encounter turbulence in flight, you should increase speed. False. So one of the things that I've got this question wrong before is like when you are hydroplaning, you want to hit the brakes more. Not wrong. That's a bad example to use. When you're in an airplane and you hit turbulence, you want to slow down. You don't want to increase speed because that's going to increase the turbulence. Increasing speed, increasing turbulence. So when you're in flight and you hit turbulence, you want to slow down. Okay. Now here's number 3. Wingtip vortexes are created when an airplane generates lift. The greatest vortex occurs when generating aircraft is heavy and slow. Yes, that is true. So wingtip vortex is caused when the airplane's taking off and it's heavy and it's slow. So just think about a big mass moving through the air for the first time. It is distorting these waves. Just think of a big airplane taking off. The wingtips, that's when it's slow. When you're going fast, it's just cutting through the air. When it's going slow and you're taking off, that's when it's first generating lift. That's when it creates the most wingtip. That's when it creates the most vortex. Okay. All right, here's one. A change in wind speed and or directions in a short distance is it's called wind shear. Okay, so a change in wind speed and or direction in a short distance. A change in wind speed and or directions in a short distance. So wind shear is all over the place. All right. So a microburst is a type of wind shear. Yes, a microburst is a type of wind shear. Just remember that a microburst is a type of wind shear. So whenever you're taking off with a microburst, you're coming up, and it's helping you take off. But then, so the wind shear makes a shape like this, and so you're taking off. Here's your plane. You're taking off, and it's helping you take off. But whenever you come to this side, it's going to push you down. You don't want that to happen. Okay, the weather-related hazard to aircraft that can accelerate forward and downward speeds, causing aircraft to crash on departure or landing, is called microburst. Yes, so departure or landing, that's when microbursts are dangerous because you're taking off and it can push you back down to the ground or you're landing. Okay, a large downburst producing an outflow of wind in excess of 2.5 miles horizontally, lasting 5 to 30 minutes with speeds of 135 miles an hour is called macroburst. Okay, so a large downburst producing winds of excess of 2.5 miles horizontally, lasting 5 to 30 minutes with speeds of 134 miles an hour. That's microburst. Think of macroburst as big burst, microburst as little burst. So you think of all this information right here. 2.5 miles. Lasting 5 to 30 minutes with X speed. So this is big. Microburst is when you take off. Macroburst is big bursts. All right, here's question number 9. What type of aviation hazard is considered cumulative in nature? Icing. Very easy. So you build up more ice is a hazard that you're building up more of, especially when you get to those high altitudes and you're building up ice while you're flying, or that you don't have to be in high altitudes, but you're building up ice as you're flying. Which characteristics is typical of clear ice? Very, very simple here. Smooth. Think about when you walk outside and you got ice on the ground. It's smooth. Like ice puddles. So, a form of inductive system icing would be ice blocking airflow into the carburetor. So, inductive system, that's where the engine is taking in, air and fuel. But, so one of the options is fuel freezing in the fuel lines between the tank and the engine. It's going to have to get really cold for that fuel to freeze. You're more likely to have ice blocking the carburetor, not allowing air to come into the carburetor. Intensity levels for icing are trace, light, moderate, and severe. Okay, it's got some other options. Trace, moderate, severe, extreme. Just remember it ends with trace and ends with severe. So TNETs ends with trace, ends with severe. All right, what can contain almost all of the phenomena that creates hazards to aviation? Thunderstorms. All right, precipitation begins in which state of the thunderstorm? And that is going to be the mature state. All right, most tornadoes are a product of which type of thunderstorm? And that's going to be a supercell. Just think about tornado, just think supercell. What type of clouds would indicate convective turbulence? That's going to be towering cumulus clouds. So, convective cumulus, towering cumulus clouds. Where does wind shear occur? It occurs in all altitudes in all directions. Wind shear, all altitudes, all directions. What feature is normally associated with the cumulus stage of a thunderstorm? That is continuous updraft. What conditions are necessary for the formation of thunderstorms? High humidity, lifting force, and unstable conditions. Thunderstorms reach their greatest intensity during the mature stage. Thunderstorms, which generally produce the most intense hazard to aircraft, are small line thunderstorms. So squall line thunderstorms. Squall line thunderstorms are hazardous to airplanes.